What is your name and where are you from?
My name is Czekanski-Moir and I'm at the University of Oklahoma.
What are you doing in Panama?
I'm studying ant community ecology.
And what's your big question?
I guess my big question is how do the traits of organisms and the geometry of their resources interact to create patterns of species diversity and richness?
And what do you expect to find?
Well, in the experiment that I'm doing, I'm adding food to a tropical leaf litter ecosystem, so just the forest floor. I'm putting food out and seeing how many ants come to the food. And I'm putting out the same amount of food in each different plot, but I'm varying the amount of times that the food is divided. So in some plots I put out just one big plop of food, and in other plots I put out 64 tiny little pieces of food, but all of the same total mass as the big plops. And so what I'm expecting to find is that there'll be more different species of ants at the many tiny little pieces of food than at the big plop.
What observations are you making?
So when we go out into the forest and put the food out, I collect about once a week to see just which ants have come. So I'll actually collect ants from these pieces of wax paper with food on them. And then at the end of the experiment, because it's a long-term, it was a month-long experiment on resource dispersion, and I'm going to collect all the leaf litter. So I'm just going to collect all the leaves and then try and coax all the terrestrial arthropods out of the leaf litter by putting it in these things called Berlese funnels. So we shake the leaf litter out and then put it in kind of a funnel and then shine a light on top, and all the little arthropods kind of run away from the light and then they go down, but what they don't know is that underneath them is a very smooth-sided funnel and then a cup full of poison preservative. We're using ethanol. So we're going to destructively sample the entire communities at the end of the experiment.
How do you collect your data?
We do the Berlese samples and just collect by hand periodically throughout the month. And then I look at them under a microscope and try to identify them as species. Well, I think from a theoretical standpoint, my research is important because a lot of ecologists have neglected to study the interplay of traits of environments and traits of organisms in producing patterns of species diversity. But from a more immediate conservation perspective, land use planners often have limited resources, financial and land space and anything else that you can think of to work with. And I think trying to maximize the ability of species to live together is in the best interest of conservation biology. So conservation biology, I think, is kind of a practice. It's not as much of a science as ecology is. It's more like medicine, where you try and go out and you fix problems, which I think is really important. And what I'd like to do with this research is give conservation biologists the tools they need to make decisions about how best to slow extinction of species. I think slowing species extinction is a really just ethically important thing. And I guess that's just the way I feel about it. I don't know if I can justify that.
How did you become interested in science and research?
Well, my parents met because they were both camp counselors at a nature camp. So that's kind of ridiculous. And my favorite activities when I was a little kid were reading field guides and turning over logs to see what was underneath them. So I was always really interested in the natural world and just in natural history and everything. Partially because of my parents' enthusiasm, I'm sure, and partially just because I don't know, we had a nice backyard. But kind of more immediately, what really made me make the decision to go back to graduate school was I was working for a few years in an island nation called Palau, which is a small group of islands close to the Philippines. And I was working as part of an ecosystem-based management project that sought to gather information about ecosystems and then give this information to policymakers and stakeholders so they could make sort of scientifically informed land use management decisions. And what I really felt about this project was, on the one hand, I felt really empowered because I was gathering information that wouldn't have been gathered. I was contributing to science. I was finding new species in this island. And I was actually giving these tools to some policymakers. We actually changed the way their equivalent of the EPA makes land use permit decisions and stuff. We said you should look at the ants also and take that information into consideration. We told them how to do it. But at the same time, I just had kind of a nagging feeling that there were more interesting and more robust ways of doing what we wanted to do, of doing the ecology behind studying forest health in different contexts. And I thought that I needed more training to be able to do that. So I guess what I'm hoping to do with my graduate school career is learn how to be a better ecologist so that I can empower conservation biologists more effectively.